go. 20 minutes. Okay. No more. Oh, watch out, watch out.
I'll do my best.
Okay.
Slides. Okay.
It's okay now.
So ChatGPT is great. The title was very boring before that. Yes.
There you go.
Oh, there you go. So, me, I'm Mark McMahon, Senior Principal Engineer at Autodesk. I keep getting pushed into non-coding roles. I keep trying to fight that a bit. Sorry, okay.
Yeah.
And then I'm currently catching up on loads of reading that I should have done probably much earlier in my career. Okay, so this is what I'll talk about. I won't go into the agenda now, but just go straight into the topics. So, what are some properties of iterators? They're efficient, they're zero cost, throw stuff in goes to zero cost, so they're zero cost. They use static dispatch and they allow the bounce check, so you're not checking whether your iteration is past the bounds of what you're iterating on. They're lazy, so if you've got 1 million items and you're only the item you want is only after 100, then you won't process the rest. And then they're very composable. You can attach a lot of functionality and chain it together. So using iterators, are using iterators hard? No. You just use an iterator. So have a for loop. There's an iterator in there. You can't really see it, but it's there. So part of the desugaring of a for loop is converting the array or vector that you're iterating into an iterator. So using iterators is simple, right, at the very basic level. So let's dive into some of the more explicit usages. So yeah, one thing I wanted to say before continuing is that this is from the Rust docs. If you don't do something with the iterator, if you don't collect it, if you don't, in this case, collect, nothing will happen. The iterator is just sitting there, and you think you've iterated all the items, but until you say, give me all the items, or give me the 10th item, nothing's going to happen, unless you give you a warning.
Interesting.
Okay.
Interesting.
Yes, so you can collect your array into an iterator. So question, will this work? And it won't work, so why won't it work? Anybody know? It's subtle. So the error you get with that one is that it doesn't know the type you're trying to collect into. And so you need to tell Rust what you're collecting into. And here it suggests, yeah, it's probably a vector you want here. And sure, I can do that. Yeah, right, vector. So, and this compiles, and this works, and you have the output is the same as the input. You can also use Turbofish to specify what output you want. In other situations, it might be harder or it might be painful to add a type here. You can specify the type here. So that weird colon angle brackets is called Turbofish.
Oh, question?
Sorry? V is badly named. V is an array. It's I guess it's a slice, maybe. I never know. Asserts don't necessarily have to match type. You can assert a string against a str, and they will compare equal. And I use that a lot in the slides. So this worked. I didn't need to convert it to I didn't need to convert this to an array, for example.
Just a quick question. Do we need to explain vector or V first?
No, I meant like just like
okay, why the change? Okay, cool. Yeah.
But yeah, if you need to stop me, I think I'm going too fast anyway, so please help me slow down.
It's all right. You're good on time. Don't worry.
So I wanted to point out that a string is also a container. You can collect an array of strings into a single string. Probably not the best, probably not exactly the easiest way to do it, but you can. I wanted to spend a bit of time on collecting into results. Results are the sort of error type for Rust. Instead of returning or throwing an exception or returning an error type, well, result is the kind of error type. It can either be OK or error. If it's error, it signifies that whatever process you were doing failed, and if it's OK, it says, OK, that worked, and here's your value. So if you want to get all of the results, you can say, collect these items into a vector of results, and you'll get essentially the same thing. It'll be a vector, of course, but you'll have an error, an OK, and an error, which is what you want sometimes. But a lot of times, you're more interested in saying, I'm doing something and I want to get all the OK values if it worked, and I want to stop and get the error if it didn't work. And so here, we have an error here first. And what this collecting will do is it will start iterating over, find the first one is an error, go, no point going any further, I have an error because I've collected into a result of vec. So you can see here, this is the other example where everything is okay, and we do exactly the same collecting and same type, and here we get the okay values. So this is very powerful if you've got some operation that can fail and produces a lot of items. Additionally, if you want to get all of the failures, sorry, do you have a question? No. Okay, sorry. If you want to get all of the failures and all of the successes, and you want to get those into separate vectors, if you use partition and then say result is error, then you can actually get all of them. Yeah.
But here, that's not really what you want to do, because now you have two vectors of results, whereas by the partition, you can select one of them to be a vector of string, and the other to be a vector of whatever error. Like, it's very good size, you go for the size per time.
I'm not sure. Here, this first one, the failure, will be a vector of results of string.
But that's the thing, you know much more than that, right? Because you know that all the elements are going to be errors. So all the elements are going to be left values. In the other vector, all the elements are going to be right values, because all the elements are going to be okay.
So you say you could unwrap the error and unwrap the okay and unwrap the value?
I guess what I'm saying is in a partition, you want to use something, like I hope there is such a combinatory class, I don't know, that does this 5-level split for you, not just the value levels. Like if I give you a list of result A, B, then you give me back a list of results A, sorry, like two lists of results A, B, that's not as useless. I'm going to give me the list of A and the list of B, then the types tell the whole story, and also the types.
There might be, but I'm not aware. It could be.
I'm just pointing out.
Okay.
Yeah, as mentioned earlier, being mindful of time, mainly, in an opinion, but we can ask later on.
Okay, so iterator, so v.iterator is returning an iterator, and we can call methods on that. And map returns a different kind of iterator, and again, you're calling an iterator, calling another method on that. Filter, again, is another method of iterators. Here, we're just going over each of the items, converting it to lowercase. If it starts with W, filter it out, and then get the second item. So this is powerful. It can be overused. I've found it overused sometimes in my code where I'm trying to do too much and would be clearer in a for loop. And then finally, we get the rust out because that's the second item after we've removed word. So yeah, I kind of touched on the last slide. So some methods return another iterator. This is returning an iterator, and the input needs to be, don't have to worry about it too much, but, and some methods don't. So this one returns an item. You're saying, if this item is in the iterator, then return the first instance of it, and if it isn't in the iterator, return none to signify there isn't one. There are a lot of methods, 70 something counted, but I forget. So I'm not going to go through all of those, and I really recommend you look at the documentation to know, to go into detail, find out which ones you think might be most useful to you. Okay, so I didn't touch on borrowing, ownership, and mutation, subjects that are very common and important in Rust. I won't be going too deep into them. When you do iter, you're actually borrowing the item. You're saying, yeah, I want to go over each of the items. Sorry, I want to go over each of the items, but I'm not going to take ownership of them. I just want a reference to them. When you say into iter, you're owning the item. You say, I am taking that item. The items in V are no longer usable by V. V goes away essentially after that call.
That's a known problem, by the way. Can you imagine every time we pitch, suddenly the slide goes on and you keep going? That's a known problem. No worry. It's not you.
So if you want ownership, if you're trying to do something with the item and you think you need ownership, remember into iter rather than iter. You can also iterate mutably. Again, just a slightly different method here. So if you call itermute, you get a mutable iterator, and this is dereferencing the item and then adding 2 to it. And we see afterwards that all our items have 2 added. It's the same here. It's not a new vector. It's the same item that I passed in. Okay, so we can make our own iterator. It's not that hard. So is vec an iterator? I use vec here, but array could have been, because that's what I've been using on the slide. It's not really, but we've been using it as one. So what we do is when we call iter, which is a method provided on vectors, it gives us back an iterator. There's also this into iterator trait has been implemented for vectors. So the into iterator is what we call into iter, and the iter method is just a method of vectors. And here we can see from the vector documentation that it tells us that it's implemented into iterator. So traits, I think Bud will be going deeper into traits later. They're kind of, I won't be going into deep, but they're essentially like interfaces or abstract classes in Loop. And there are 3 iterators that are useful to us, or 3 traits that are useful to us for iterators. The iterator trait, and all you need to implement is next, and then you get all of that, all of those methods like find and nth, they all come for free. There's the into iterator trait, which allows you to grab an item and turn it into an iterator. And then from iterator trait allows you to take an iterator and construct your own type from it. So we'll be creating an iterator of this and collecting into this type. It's not a brilliant example, but it's nice and short and fits on slides pretty well. But usually iterators are to do with collections, not to do with a type like this. So we'll do test-driven development here, and we'd like this test to pass. So we'll construct a new item struct, we'll iterate over it, we'll call next number of times of the items, and once we're done, we expect that none will be returned. This is how iterators work. If this works, then a for loop will work as well. And so this is the implementation of an iterator, and it fits on one slide for that object. We need to create, so if you remember the item struct, it doesn't have anything to say, this is where you are, you're in between the first and the third, or first and second item. So we need a new, we need a new type which will track where we are in the iteration. And so we have an index and we have a reference to our item struct that we're iterating over. And then we say, we want to implement the iterator trait for item iterator. And we're saying that when the item that's returned will be a string reference. And then we implement the next method, which I said is the only method you need to implement. And it returns self item. And most of that you don't really have to remember. You go to the docs and go, what does the iterator trait require? And it'll tell you, oh, well, this is the, more or less, I mean, it's not exactly the same. You have to do some work, but you can get a lot from the docs. For iteration, what we're saying is, okay, based on our current index, select either the first, second, or third item to return. And we'll be going into more into match statements. Okay, so that implemented iterator, but how would you get the iterator? So I followed the pattern that they had for VEC, which is you just provide a method which call it iter and will return the iterator, and it instantiates the type. So the index is 0 and passes the structure. Okay, there, a sort of late addition to the slides, I was seeing that there was this from function, there's an iterator from function, and it allows you to create an iterator without having an additional type. There's a closure that's run each time, works exactly the same. That's it, okay. From iterator, I'm almost done. Again, we want the test to work, so we have an iterator, so we've called the iterator into iter on that, and we have our item struct, and we're saying, oh, we want to collect into item struct. And so this test should work. Again, the complex signature of the trade and the function you can get from the help. It's very little extra work you need to do. The interesting thing is that the type that this function takes is not an iterator, it's something that you can call into iterator on. I don't know the exact details, but I guess it makes it a bit more flexible. And so the first thing we do is we call it into iterator, and then for each item we apply it to our item struct. I highlighted the unwrap here because you can't change this to a result self. It has to succeed, and so the only error handling we can do is to panic. If you really wanted to construct this type from an iterator, you'd probably be better off implementing the from trade for the iterator, where you could handle errors. So, in summary, using iterators is easy. You have a lot of powerful options, even without writing your own iterators when you collect. There's tons of useful methods, you can chain them, you can provide a lot of useful functionality. And then writing your own iterator, I won't say it's easy, but it's quite approachable if that's what you need to do. Thank you.
Thank you. Any questions for iterators?
Oh, we're still iterating. Okay, all right. I noticed there's a good few new people here. Sorry, your question?
Yeah, for one slide.
Okay.
There were two different lines, right?
Yeah, there you go.
I'm too late to go back.
So there was one slide with two lines, right? One there is the method iter, and another one there is method into iter.
Yeah.
So the time I saw the n%, so is the first one, let me guess, it's to take the reference, right, of
The ampersand means it's a reference, yes.
the range of the private things. Then the second one is it to copy it? Right?
No, it's. I remember now the slide you're talking about. So the first one was iterating on the collection, and you get a reference. So the original collection still has the item, and you just have a reference to that, and it's a read-only reference. So you can use it, but you can't modify it. And the original collection has to stay alive, or else Rust compiler would say, no, you can't keep the reference. The second one, it doesn't copy, it says, you are now owning that item, and the original collection or iterator no longer has it. So it's been moved to your ownership, and the original iterator or type is gone.
Sorry, did it answer the question? I'm just being mindful.
Yeah, he did.
Okay.
That was the answer.
Guys, I have to apologize one thing. Sometimes the mic can be very inconsistent. We have this problem every week.
I think because it's more so configured for this one.
Yeah, exactly. So for the speakers, if I can, if you just move to the front, speak a bit louder, okay? Yeah, again, this is something beyond my control.
This mic.
Yeah. So again, now, I did notice a few new people came in. I made a mistake and I want to kind of write this very quickly. For people that's relatively new, if you're very new to Rust, this is the slide that we present in the previous meetup. You actually can do some review and you can keep this for your own reference. My sincere apology. I should have done that. And we went straight to iterators. My bad. Because some people are like, what? Yeah, my bad. I'm very good at looking at people's eyes.
I only know about iterators from my people who look the things they use iterator.
That's correct. That's correct. So iterators, patterns are all called matching, and later on. So yeah. So again, for people that just come, if this is your first time, my sincere apology. I should have put this up. You can keep them for your own reference in the future. There's here on the left hand side is introductory concepts. I never had time to go into ownership and borrowing, but maybe next time. But it covers some of the basic fundamentals. That one here on the right side, my cousin actually, I gave him a challenge. He came from the world of JavaScript. And I said, try Rust, and he absolutely hated it and cursed at it, and I got him to present. So again, you're okay to love and okay to hate. Oh, he's saying, nah, he's going to stay in JavaScript. Doesn't want to go anywhere. So again, this is for you, okay? Everyone good? Okay, all right.